So this section is for so this is the load. This one is stored in an array. This is a shiftable load, shiftable profile load. So here the start are decided by the optimization algorithm, and initially we have declared the MB load and the AF load that are fixed loads, and base load 1 is actually MB load for 24 hours, and base load 2 is AF load for 24 hours. So here is a for loop from 0 to 1, 364 means there are it will run for 365 days, and here A and B is just repeating it, means this is just to convert this 24-hour profile to an annual profile. So the MB will be length, instead of 24 hours it will have 8760 hours, because in a year there are 8760 hours. If we multiply the 24 by this 365, then the answer will be 860. This. So the hours in a year are 8760. So these two lines are just to convert the 24-hour profile to an annual profile. So it will be repeating this one, and this base load will be appended after each 24 hour to this MB load and to this AF load. So these are the fixed loads. We have no choice to reschedule it. So the only in the shift profile load we have to choice to repeat this 24-hour load, that is mentioned here through this shift start R variable. So start R here is H1 is the R from where the load should be placed. So actually this optimization algorithm has a choice to start to shift this the profile of this load anywhere to this one. So we have declared a variable start R here. So this is selected by the optimization algorithm, and this is day multiplied by 24, means after each we are giving H1 is the starting R for each day. This is when D start from 0, then it will be 0, means it will be just the start R. Suppose if it's 7, then it will be 7. After the next day there will be because the second day the hours will start from 25 to 48, because for 24 hour we are going from 0 to 23 or 1 to 24. So for the next day will be move on from 24 to 48 and so on. Suppose from this, then from next 24 hour will be from 25 to this 48, and then for third day it will be 49 to 72 up till this point, and then so on until it is 8760, because there are 8760 hours in a year, because we are doing an hourly simulation. So to convert this in hour, day multiplied by 24 plus starting hour. So that will be the starting the placement of this shiftable profile in each day. To convert this in hours, so here is HD load. So where it should be placed on each day, this is shiftable load will be placed at this index starting from H1. H1 will be decided by this start R, just added with this day, at which day we want to add this one. So it will be run for the whole year, and this will be the starting point H1, and to how much point this load should be played is dependent on the length of the shiftable profile load, because if it has a length of 8 and we are starting and fourth point like this one, if it has a length of 8 and we want to place it here at fourth place at this one, then this one plus 8 somewhere there. So this should be the starting point start R, and plus after adding in this, or if it is the starting point is 9, adding 7 in it, then this will be the ending point. So this is the starting point and ending point. This one is H1 is the starting point of each day, and this is the ending point where this shiftable profile should be appended for the whole year. So this is shiftable profile load, and fixed load is adjusted throughout the year. The shiftable profile is adjusted by this start R that's selected by the optimization algorithm. So we have a base load that should be met in each R at that position. That's we call it a new load. So it is the summation of a fixed load, one, the fixed load called MB load. The second one is this, also AF is also say the SG load is shift profile load for the whole year, having 8760 entries R's. So its load is its profile is shifted through this start R. So this is our base load. We have to meet this load at each and every cost. So we have pending the DU1, DU2 and DU and FF. So these are adjustable load at any R. So initially these are declared as null, as 0 for 8760 hours because we are just starting the simulation. This is the grid purchase and sale. Also it's null because we are just starting the simulation. So here it's the main simulation from this one to up till this one, up to this point, up to this point. This is the totally the for loop. This is the main operational strategy where we will place this DU1, DU2 and FF load. So these three load will be placed in this for loop. So this is the operational strategy will be run for 8760 hour for the placement of this DU1, DU2 and FF load, and how much energy has to be purchased to the sold to the grid, and how much energy has to be taken from grid. So actually this is an optimization algorithm main. So here it's input solar whatever the load, the radiation, the modeling of PV and wind turbine. We have done this. So you have to run it for 8760 hours because it's an early simulation. So we are first of all we are checking the balance. If the renewable is greater than load demand, then we will call the surplus function. If it is renewable is not greater than load demand, then we grid purchase function, and we will be simulating this for 8760 hour. After that we will call a function, economic cost function, that will calculate the LCOE, annualized cost. So this will be the operational strategy of our system. So going into further detail, what will be done in the surplus function and the grid purchase function, as indicated by the name, that it means that the load, basic load is met by the renewable energy source. So we have to manage in the surplus load, either we have to sold this extra energy to this grid, or we have to manage the shift volume load. And in the grid purchase, as indicated by the name, so we have to purchase the energy from the grid to meet the load demand. So going into detail, the surplus function. So first of all we will limit the shift load operation. I will what does it mean, the limit shiftable load operation hours? It means that if we have load 5 or whatever load, if had 1 2 3 4 5 6 7 8, so if it should be operated for 8 hours, so we should operate we should limit its operation till 8 hours. It should not be exceeded where it is, so it should not be operated beyond 8 hours. Similarly for DU1 and DU2 load, there it is 16, so it should not be operated beyond its maximum operational time of in hours. So we will limit this one. How it's implemented in the code, later on we will discuss it. So then after that, as in the surplus function the renewable is greater than load demand, then it means that we will be checking if the extra renewable energy available can meet the DU1 load. Yes, if yes, then DU1 load will be included, will be operated for this specific hour, and load will be updated. Otherwise DU1 load is not renewable, cannot operate this one. Secondly, as the DU1 is the largest one, the second largest one is the FF. So we are checking if the renewable energy can meet the FF load. If yes, then add this FF load to the load, turn this load on FF, otherwise cannot operate this FF load. The lowest load is the FF load, sorry, it should be DU2 load, here it is, and DU2, here it should be also, again here it should be DU2. So we are checking if the remaining after meeting either this one or this one. So if the DU2 after the surplus can meet this demand, if yes, then also adjust the DU2 and update the load demand for this specific hour, otherwise don't operate it. If after meeting all these conditions or meeting this load demand, there is still surplus energy that will be used to sold to the grid, and this surplus function will end. So the other function is grid purchase. In the grid purchase, we have only requirement that our load is deficient. How much is deficient? This is our load demand minus whatever energy will be provided by the renewable energy. So that's the remaining deficient amount that will be purchased from the grid. So that's about grid purchase function. So before this one, this is the main operational strategy, this for loop from this point to up to this point. So in this thing there are two sections. First, to check whether the renewable energy is greater than load demand or not, and the other one is to check the operationability of ours. So in the first section, let's see, this section is renewable is PW plus inverter. It is just to convert the 8760, the whole year hours, in 24-hour format. It means T is the time for the whole year from 1 to up to 87 hour. To convert it to a 24-hour format, HR is a function. If we divide to T by 24, the remainder will be an hour from 1 to 24. So for each 24 hour we are checking, this is maximum hours in a day, 24 hour, at which hour we are operating. Suppose we are at 20th hour, at the 20th hour in the evening, and there 4 hours are remaining, 24 minus 20. We have to check for how much is the count remaining for this DU1 load or whatever load. Suppose this load 5, let me call it a DO2 load. So suppose this is operated for only 3 or 4 hours. 4 hours. 1, 2, 3, 4 hours. So this load is operated for 4 hours and we are at 20th hour. So we have just left with the 4 or 5 more hours. So this energy necessarily should be, this load necessarily should be operated. What I mean, so these last 4, 1, 2, 3, 4. So if I move it and we are at this 20th hour, 19th hour means at this one, at this point or below this point. So we are at this point, at this hour or at this hour, and we have just operated this load for this 4 hours. So it is necessary to at minimum at this last 4 hours we have to adjust this load at, so the count will be 4 because this load is operated for 4 hours. So here we have remaining the 4 hours because we are at this point, we are at this, the last 4, 1, 2, 3, 4. We are at this point, at this point 1, 2, 3, 4 at 20th hour. So we have 4 hours remaining. So this load necessarily should be met here at this point, because the 4 hours remaining, the count is 4 and the maximum count is 8. So the maximum count of this DU1 is suppose 8. So let's talk about DU2, where it is. Here it is. So the maximum count of this DU2 is, sorry, FF. We should discuss FF load. So this is the FF load. So FF load should be operated for this 8 hours minimum, and we have left with this 4 hours. We are currently at 20th hour and maximum 24 hours there. So 4 hours are left. Maximum count is 8. It means that this load should be operated for 8 hours. For 8 hours this load should be AF, this DU2 or whatever you call it, FF load or whatever you call it. I am just giving a dummy load, dummy name. So name it as FF load. So this should be operated for 8 hours. Up till now this is operated for just 4 hours. FF count is 4. Sum of this FF count. It means the alarm situation has come. You have to necessarily adjust this FF load, because you have just remaining these 4 hours, the last 4 hours, and you have no choice other than to operate this load, because 4 hours are left and you have to operate this load for 4 hours. So if it is yes, then it means your load for this specific hour will be increased by this FF load. So this FF load should be operated, and FF new means at this specific hour this FF load is operated, means rescheduled. So this FF new is actually the rescheduled FF. So it is operated at this specific TR. So if it is operated for this specific hour, we are making this 0, because the load for this specific hour is met. FF count is equal to 1. So for this specific hour, this FF load is operated. FF count at R, this specific R is equal to 1. It means that for this specific R, this FF load is operated, means make it count is equal to 1, and so on. So similarly for this DU2 and DU1. So we will be checking if there is a possibility that the remaining operational hours are less and this load is not operated, operational hours is less than this remaining time. So in these three sections, for this DU1, DU2 and FF, we are only checking that if the time is less than, if time is less remaining and more for more hours, this FF load or DU load or DU1 load has to be operated. So we are ensuring all these parameters in this one. So the operational ability time is ensured, and these for each load in these 3 sections. These 1 section, 2nd and 3rd section. So in the other section, this one, we are checking either we have to go to surplus section or to grid purchase section. Into the surplus function, if I open the surplus, if renewable is greater than load demand, so this is actually our rescheduled or updated load. So if it's greater than, if renewable is greater than this load demand, so we have to call the surplus function. In the surplus function, again the same counts are. Count at specific R, HR is equal to 1 means like this one. This DU load is operated at this specific R. It means this one. Similarly, DU1 load is the magnitude of the DU1, DU2 and FF. So new means DU1 new, DU2 new, FF new means the rescheduled FFR. This is to ensure that these 3 lines, to ensure that if the operational hours of this load are, this load is 8 hours, so we are also ensuring that this load should not be operated beyond time. In the previous section, we was ensuring that it should be at minimum in the whole 24 hour, it should be operated for at least 8 hours. What now we are doing that it should not be operated in the whole 24 hour for more than 8 hours, this load. Is it okay or not? So here in these three line, if the du max, if this count is greater than this du max, then it means that make this load 0. We don't want to operate this load anymore, because whatever was the amount, it's the count. Count means for how much R this du1, for each R this is, for any R this load is operated, that is the count of that load. Because if the FF is operated for 7 R, then its count will be, summation of this count will be 7. So if it is operated, should be for maximum for 8 hours. If it tries to operate for more than 8 hours, as this maximum the operation time of this one is 8, then this f function, this will stop it, will make this load 0. So similarly for du1, for du2, for du3, so this will be maximum operated for 16 hours, du2 for 16 hours, and ff for 8 hours. So this is limited by these max functions. So max du1 max, du2 max, and ff max is the operational time of these one. So here again, this is a very simple logic for rescheduling of this du1, du2, and ff load. Here you can see this, we are just checking if the renewable is greater than present load demand plus du1. If it can, additionally with this load 1, if it can meet this du1, then adjust this du1 in this new load, increase its count, and update this rescheduled du1 new. So this is just like we have mentioned in this surplus trajectory, this one. Check the renewable, if it can meet this du1 load, then operate this du1, otherwise go on for next one, and then for check for ff load, and then for du2 load. So the same things are checked. Then next check if the renewable can meet this new load, along with this new load can meet this ff load, then adjust this new load, this ff load in this load management, increase its count, actually this is not required, I'm deleting it. So this is a rescheduled load, because for this specific R this is operated, so add it in this rescheduled load. Similarly this is for du2 load, check if the renewable is greater than this new load plus du2, means it can meet along with this load demand, can also meet this du2 load, then adjust, add this du2 load in the new load, managed load, the rescheduled load, increase the count of this du2 at this specific R, and du2 load, this is the du2 new means the rescheduled load, add du2 in this one because we have operated this du2 load. If still we have extra surplus energy, renewable minus the updated new load, then sold that one to the grid. So exactly in the same way as mentioned here, all this one du1, du-ff load, du2 load, all are checked. If there is still extra energy available, then it's sold to the grid. So not now going towards this grid purchase, because in this main section, if renewable is greater than load demand, then go to surplus, otherwise to else go to the purchase section. In the purchase section, we have to purchase the energy from the grid. So in the purchase section, we have only one thing, that we have how much energy has to be purchased from the grid. That's dependent. This is the new load managed are required minus whatever provided by the renewable energy. So the difference is that has to be purchased from the grid. And for last one, this economic cost function is called, these are the inputs to this one, number, size of the wind turbine, size of this solar, grid purchase energy, grid sales energy. So it in return it will give us annualized cost, wind cost, solar cost, grid cost, inverter cost. To calculate the annualized cost of energy, annual cost divided by total load served, so it will give us a levelized cost of energy.